And now let us look at an example of a contradiction. Consider this complicated expression, not of P implies Q and Q. My question is, if you write the truth table, how will the truth table of this look like? Can you guess without writing the truth table? Okay, so let's write the truth table right now, and then let me give you a tip on how to do this even without writing a truth table. So P is, as and always, 0, 0, 1, 1, Q is 0, 1, 0, 1. What is P implies Q? We have seen enough of it. 1, 1, 0, 1, right? Perfect. What is not of P implies Q? We are basically going step by step. Not of P implies Q will be the negation of P implies Q, which is 1 becomes 0, 1 becomes 0, 0 becomes 1, and 1 becomes 0 here, as you can see. Right? And then this column and Q will simply be 0 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and hence the column corresponding to your expression, not of P implies Q and Q, happens to be all zeros, and hence a contradiction. Now look at a very different way of showing that such a truth table should end up having all zeros in this expression, below this expression, that column, right? So how do I show that? When, on the contrary, let me assume that this becomes 1. How will it become 1? Let me see. Q has to be 1 for this expression to be 1. When Q is 1, this Q becomes 1. And no matter what P is, 0 or 1, okay, this implication will become true. And when this implication becomes true, not of that becomes false. So false and Q. Whenever Q becomes 1, this expression on the left side of and forces itself to become 0. Think about it. And hence this is always 0. You can never make this become equal to 1. It will always be equal to 0. You may want to understand this carefully by maybe watching the video once more and trying to figure it out all by yourself.